Hello everyone, welcome to a brand new lecture of Bytes of CC, and in this lecture we'll be discussing about how to map the entity relationship diagram or a schema to a relation table. Now this is especially important if you are appearing for any competitive exam like GATE or NET. So for those exams you really need to know the mapping. So let's get started. Now for this particular lecture, I will be referring to the entity relationship model which we discussed while I discussed the entity relationship diagram basics video. So if you haven't gone through that, I will be linking that in my description box. Do go through it. And now let's get to the main part. Now when we are preparing a database schema from a model like this, there are two things which we need to remember. First of all, there should not be any repeating tuple or data in your uh, database table. So that's number one. And next, when we update a particular value, because often we need to update some values, and for that purpose, preferably, or actually, it is a norm that one value will be stored in only one table. Like say you are trying to update this student name in this case. So it is an entity student, and it has a this has an attribute name, and now if this name appears in more than one table, so when you're trying to update this name, say there is a spelling mistake or something, then you will have to update that in only one table. If it appears in more than one tables, you will have to remember what are the tables where the name appears, and then you have to update that name in all those tables. So this is something which is not a good design. And actually your database table has to be of at least one normal form. Now if you are not sure what one normal form is, you don't have to actually bother yourself. For this lecture you will just need to remember these 2 points. So preferably only a single tuple will be updated, and moreover there wouldn't be any redundant or repeating information in your database table. So now let's get to this particular case. This is a 1:1 relationship between a student and a room. Now the student is enrolled in a university, and in this university every student actually requires to stay in a hostel, and every student is given a single room. So now there's a relationship allotted which exists between the student and the room, and now we need to somehow link this student and room. We need to link this relationship. Now there can be one option where we can actually add this student ID. We now in this case we consider that this roll number is the primary key for this entity student, and this and for room number and for room number is going to be the primary key. Now if you're not sure what a primary key is, in one word, primary key is something that has a unique value for every row or every tuple in your database table. Now there is another video on keys that I've already done. You can go through that. I'll be linking that in the description box too. Now see, in this case, now this accommodates or allotted, whatever you call it, now this will actually contain the roll number of the student. So for this particular actually representing these two entities and the relationship, so now we will have one table which will contain the attributes of the students like name, roll number, address, contact, date of birth, and then we will have another table. This is table number 2, which is a room, which will contain the attributes of the room. Now in this case, in this particular case, this can also be done in another way, like if we merge or if we link the room number with the student part, like student table, like in here we actually adding this room number attribute to the student, and that actually relates student with the room. Now when we are doing a join operation, like when we are joining these two tables, we will be mapping this room number with this room number of the room table. And if we are using this one, if we are merging this on this room table, we will be linking room and student using this accommodates attribute, which is nothing but the roll number of the student. Now this will be equal to this roll number. So using this mapping, we can actually establish the relation. But in this case, since all the student has to be alerted to one room, so actually the association between the student and room is a total participation. Now in case there is a total participation in a 1:1 relationship, in that case we will be merging the relation to the table which is in the total participation. In this case, student. So if it is a total participation case, as is in this particular case of student and room, so this is going to be your joining. So we will be having two tables, your student table and a table for the room, that is for these two entities, and the relationship that is allotted or accommodated, whatever be it. So that will be merged at the total participation side, that is student side. So this is what is given here. You need to remember this part. And actually when we are linking, in any case, whatever be the association, when we are linking two tables, we will be using the primary key of the other table as the linking or the relationship attribute. Now let's move on to this part. Now this is a n:1 relationship. That is, a building can house many courses and every course will be mapped to one particular building. Now say this is your building of School of Computational Science. Now this building houses many courses like BTech in Software Engineering, BTech in IT, BTech in CSE, MTech in CSE, MTech in IT, and also a research department is also present in this building. Now let me try to merge this course ID or this contains attribute, which is actually the course ID, to this building. Now this teachers is actually the course ID. This is the course ID. This is the relationship name that I have used here. It doesn't actually matter what name you are using. So if we do something like this, now when we are, now the building contains attributes like building number, name. So building number is the primary key, and supervisor, floors, and teachers. Now this course ID for every single row or every single information will contain just one course ID. So when you are actually adding this courses information, or rather the courses relation, to this building table, so for each course ID there will be one row. So in this case there will be 1, 2, 3, 4, 5, 6 rows. And since a primary key has to be unique, so along with building number, teachers also has to be the primary key. So together now building number and teachers is your primary key for this building table. Now what happens is, we say this is for BTech SE, then this is for BTech IT, and so we are adding these many tuples. Now if we look into this part, this is a common part. So we can see that this information is getting repeated over and over again. This particular information. Now say you have 6 buildings in total, and on an average every building houses 5 courses. So now the number of tuples you will need to store in your building information table is 30. Whereas if you had to keep only information up to this, that is up to floors, you would have had 6 tuples. So now clearly this is not a choice. So now what we will be doing is, we will be merging the building information in the courses table. So this is the end site of the relationship, that is a courses relationship, and now we introduce an attribute location, which is essentially the building number. Now since each course can be mapped to only one building, therefore you do not have to introduce extra tuple. Your course ID can be the primary key and you don't have to bother about the location. You don't have to actually include this in your primary key, and basically you are just adding an extra column to your table. Your table remains the same. There is no extra information being added. So now for your 1:n relationship or n:1 binary relationship, there needs to be 2 tables, one for both the entities, here for courses and building, and the relationship is merged on the n side. So this is the rule, and this is for one side total participation and also for partial participation. The same rule holds. Now let's move on to this particular case. There should be okay, so this is missing. Okay, so now this is a m:n or n:n, whatever you call it. That is many-to-many relationship between student and activity. So a student can participate in many activities and each activity has many students enrolled in it. So now if we try to accommodate, say, activity ID over here. So if activity ID comes here, what happens is that for every activity you will need to introduce one tuple. Then you have to make both roll number and this activity ID as your primary key. So basically you have repeating information. So say a student is participating in 3 or 4 activities. So you have to introduce 4 tuples in student relation in place of 1, and then you are actually introducing redundancy because these informations will be same and only this column information will be changed. Now, if I try to introduce roll number in this activity table, now what happens here is, so for every student, you have to introduce one tuple. So again, there will be repeating tuples if you try to merge this roll number into activity, and moreover, of course, your activity ID roll number together has to be the primary key. So in this case, we will be creating one table for student, one table for activity, and now we introduce a new table, say takes part, and now takes part will contain the roll number, activity ID and date of joining. So this is basically a new table, which is the third table. This is the second table. This is the third table, which will have both roll number and activity ID as the primary key and a date of joining. So this will contain redundancy, but it's still better. This part is still better because you don't have to repeat so many information. So one update in your student, say you are updating the address of your student, so 4 or 5 tuples will be affected, and so also in this case. But here actually you don't have to, there will be less redundancy. If you're trying to update information about activity ID or activity or precedent, whatever be it, your actually activity ID won't be updated. Your activity or precedent, you don't have to bother doing anything to this table. Because when you will be linking these activity and student, you will be linking with this table, and then this table will be linked with this table. So Essentially, your student will link with text part, and then text part will link with activity, or your activity will link with text part, and your text part will link with student table. And that's how the joining will happen. So in M is to N binary relation, you will have three tables, one for each entity and one for the relation. So that's 2 plus 1, that becomes 3. Now we are considering the case where the weak entity is considered. Now in this weak entity, nothing actually. You will just have to add the primary key of your strong entity into this weak entity. So you will have two tables, one for the strong entity, and in your in this weak entity, you will just have to add the activity ID. So here actually this is going to be the meeting table. So the meeting table will have activity ID, agenda, description. So I actually have tweaked a bit, because agenda, I have made agenda as the primary key or the discriminator for this weak entity, and it will have some description, time and date, coordinator, and so on. Now let's move on to the composite attribute. Say you have a composite attribute in your entity relationship diagram, which has first name, middle name, and last name. Now, composite attribute is actually not supported in your relationship table. So what you have to do is you will have to introduce this as, like, each component will be one attribute in your table. So in this case, F name stands for first name. Your student will have F name, M name, which is the middle name, and L name, which is the last name, then roll number and other attributes. So that's all about composite attribute. Now if we look at multi-valued attribute, again you cannot introduce data in your relationship table using comma or semicolon or whatever be it. So composite data or multiple data actually is not allowed in relationship table. So in this case you will have to introduce one tuple for each of your contact information. So yes, it will be bit of a redundancy. So probably you will have to make another table with student ID and contact. So something like that has to be made. But yes, there will be redundancy if you have a multi-valued attribute information. So now that's all about your entity relationship diagram. So this you have to take a screenshot. So this actually is whatever I have taught till now. So for 1:1, in case of partial relationship, partial participation, so there will be two tables and relationship can be merged on any side. And in case of a full participation case, there will be two tables and relationship is to be merged on full participation side. In case of N:1 relationship or 1:N relationship, actually you will be having two tables with relationship merged on many side, which is the N side. And for M:N relationship, you will be having three tables, and if there is a case where both sides participate fully, there will be only one table irrespective of the cardinality or the association. So now we will be moving on to some of the gate questions which were asked. So first, this appeared in GATE 2008, so you might also expect this kind of questions in your college exams. So now it says that this is an entity relationship diagram. So M is in total participation with P. So this is the N side. Since there is no arrow, this is the one side. And P is a strong entity while N is a weak entity, and they are also in a relationship which is denoted in as R2. So now it says that how many number of tables is to be needed to represent M, N, P, R1, R2, and so on. So since this is N:1 relationship and this is a total participation, so this primary key of P, that is P1, is to be introduced here. So basically there will be one table for M, one table for P, okay, and this P1 is added to this M table. And now for this n table, well, this weak entity will be another table that is for n, and now again P1 needs to be added to this. So there will be essentially 3 tables, one for M, one for N, and one for P. So the relationship P and M, P1 is merged at M site, and here P1 is also to be introduced in the weak entity. So this is your answer. Now we move on to the next question that appeared in 2018 GATE CS. So in this case it says that in an entity relationship model, suppose R is a many to one relationship from entity set E1 to entity set E2. So now this is E1, this is E2, and there is a relationship R, and it says that this is a many to one relation. So this is the N side, this is the one side. Assume that E1 and E2 participate totally in R and that the cardinality of E1 is greater than the cardinality of E2. Of course, because this is the N side, so cardinality of E1 has to be greater than the cardinality of E2, and also it's a N is to 1 relationship, so cardinality is basically association. So for this kind of a case, so first what we have is, now this relationship will be merged to this E1 part, and also the number of like every row of E1 will be associated to one row of E2. So these are the informations that we get from this kind of a relationship. Now let me go through the options. So every entity in E1 is associated with exactly one entity in E2. So that is the answer. If we go through the other one, some entity in E1 is associated with more than one entity in E2. This is clearly not an option. Every entity in E2 is associated with exactly one entity in E1. Sorry, because this is the N side. So every entity, so some entity of E2 of course has to be related to more than one entities in E1. So this is not a clear choice. And if we go through this one, every entity in E2 is associated with at most one entity in E1. No, actually no, because this is because there is a total participation, right? We need to remember that. So in case of a total participation, every entity in E1 has to be associated with exactly one entity in E2. So now we have the last question that we'll be going through is that appeared in GATE CS 2017. It says that an ER model of database consists of entity types A and B. These are connected by relationship R, which does not have its own attribute. Under which of the following conditions can the relation table for R be merged with that of A? So there are two options. So that is A and this is B. I'm just skipping this R part for now. So either A and B are in total A and B are in a 1:1 relationship, and A is in total participation, or number 2 is A and B is in a N:1 relationship where A is at the N side. So let's go through the options now. Relation R is one to many, and participation of A in R is total. So from A to B, the relationship is actually defined. So A cannot be at the one part. So A has to be at the N part. So this is not an answer. So relationship R is one to many, and participation of A in R is partial. Again, no. Relation R is many to one, and participation of A in R is total. So of course this is the correct option. Relationship R is many to one, and participation of A in R is partial. So now if you have to be sure that yes, there is the relationship is merged, has to be merged, then This is the safer choice, that relationship R is many to one and participation of A in R is total. Always go for this choice. So that is all for today. So this is all that I had to share about ER diagram mapping to tables. So if you have liked my video, please give me a thumbs up and do share it with your friends. And if you like, you can subscribe to my channel for more such content. So that's all for today. Thank you. Goodbye.